So today we are working on our last lesson of this packet. It's lesson 96, and we are formalizing probabilities and looking at something else called mutually exclusive events. So up until now, we've been working a lot with two-way frequency tables. You can see I underlined here, formulas can be helpful when you don't have a frequency table or a Venn diagram. If you know the formula, it just really makes things faster and more streamlined. So let's look at exercise number 1. In the table below, all of the cells will be filled in as probabilities. So what we're doing now is just revisiting this two-way frequency table, and I labeled a couple of things. Part A, label the value of the bottom right cell. So when we're dealing with probabilities, the ultimate total is always 1, like 100%. Label probability of A, that's here. Probability of B is here, and the intersection, the probability of both, is here. Now, we're going to go over some general rules. The general formula for conditional probability. So what we had done, the probability of A given B. Let me just clear my screen. So if we were doing this in one of the previous lessons, talking to myself, we would say probability of A given B. So we would have used this row. So that is, here's the probability of what we're looking for divided by this. So we've been doing this with numbers, but in this case, we have a formula. This is super handy for word problems, let's say. Now we also have over here general formula for the probability of union. So it's an OR problem. So if you have the probability of one event or another event, you add them up and then you subtract the duplicates, you subtract the both. That's because the intersection falls into both categories, so you don't want to double dip on that one. So now what I've got here is just using the formula to find our answers instead of having to make a two-way frequency table. So exercise 2 says, given the probability of event L is equal to 0.42, probability of event F is equal to 0.35, and the probability of both of them is 0.23. Find the following. So before you take a look at all of these, if you want to pause the video, you can try them and then come back and listen to my explanations. So this first one, probability of L given F. Well, if we look back up here, I used this formula. I just used, instead of A and B, I used L and F. So the formula is the probability of both divided by the probability of F. So I have 0.23 over 0.35, and that simplifies to 0.66. For the next one, probability of F given L, it's reversed. You still have, these two things are the same, the probability of both, but what changes is what you're dividing by. Okay, so for this one, I did the probability of both divided by the probability of L, and I got 0.55. The last one here, the probability of L, that's an OR. The probability of L or F, add those two up. Probability of L plus probability of F minus both. And then I got 0.54. Now, what you should do for page 23, pause the video, try to do a problem, then check back, see the explanation. Then try the next problem, check back and see the explanation. So I think I forgot to record again For some reason, I paused it. I hope I didn't pause too much of it. For number 5, just a quick recap. I used my conditional probability formula again because we were finding both. I put the x in the both section, and then I solved for x and got 0.1512. Now, what I had said before on problem 6 was in this problem, they want us to see if these two events are independent. So think about that, pause the video, and see what you can do. So I'm trying to zoom in so you can just focus on one step at a time. I labeled these steps 1, 2, and 3. So if we're testing for independence, I'm using the multiplication rule. Okay, probability of A times probability B is equal to the probability of both. Now, they don't give us that, so I wrote here we need to find that. They give us probability of A, probability B, and this is an OR problem. So in order to use this rule, I need to find the probability of both. And that's what I did here, okay, to find the probability of both. And I used this formula, okay. It includes the probability of both here. So I just used an x, and then I solved for x, and I got the probability of both is 0.296. So now let me back up or zoom out a little bit. Our formula, probability of A times probability of B equals probability of both. So now I have what I need. I have A, B, and both. So I'm going to plug those numbers into my original formula. And now we're going to test it. Here's my formula. Here's where I plugged in the numbers, and they are equal. So that means these events, A and B, are independent. So take a minute, read question 7, pause the video, and then come back after you've read it. So our question is, what is the probability that a randomly selected car needs the transmission fluid or the brake pads replaced? So we're looking for an or probability, which means we're going to use the addition rule. So the probability you need your transmission fluid replaced is 0.38. Probability you need the brake pads is 0.28, and the probability you need both is 0.16. So I wrote those right over here. And then I wrote my addition rule. The probability of the transmission fluid or brake pads is equal to the probability of the transmission fluid plus the probability of the brakes minus probability of both. Plugged my 3 numbers in here, and then I combined them. So 0.48. And then here's number 8. So Josie is taking exams in math and Spanish. She estimates the probability she passes the math exam is 0.9, and the probability she passes Spanish is 0.8. She's willing to assume these results are independent of each other. So because of that, I know I can use this rule, our multiplication rule. Assuming these events are independent, calculate the probability she passes both. So all you have to do is multiply those two together. 0.9 times 0.8 is 0.72. And then part B says find the probability she passes math or Spanish. So I used my addition rule. Probability of math plus probability of Spanish minus probability of both. And she has a 0.98 probability that she would pass at least one of them.